Okay, welcome back. This is the second episode as we're talking about Kerbal Space Program. This is casual, and we are going to now take a rocket and we're going to put it into orbit. So I took our little rocket that we created in the last episode that just gave us a quick flight over the surface of Kerbin, and I've made a couple simple modifications to it. Now I'm not going to go back through the vehicle creation part, which you can probably figure out pretty quick. I'm just going to talk about the individual components that I added here that are going to help us out. So what we're going for is called delta V. All right. So delta V, now in calculus and physics and other math, right? Delta V stands for the change in velocity. So the variable is V, which is velocity, and delta means change in math. So uh, that's our true fuel when we're talking about space flight. How much delta V we can get into a flight. So what we're doing is how much velocity can I change with this rocket? Now in physics, that's really important to kind of grasp when we're talking about flying in space because we have fuel in the mass of the rocket, the mass of the fuel, plus we have the engines that run on fuel that need to push the rocket, right? And then as we spend fuel, our rocket gets lighter. So we have less mass to push around. So we only want to bring as much fuel as we need for the trip, or else we have to push excess mass around and it's not as efficient. So that's where stages come in. That's why we don't have just one giant rocket with a huge fuel tank, because yeah, that'll get us up there. We got to carry all that fuel with us. But you can see here I have several different stages. So I have the solid rocket boosters that I have here. Now those, kick off and I can't control them once they go, just like a firework, right? So then there's a stage here where those break off, but I'm going to start the main engine down here at the same time, but I'm going to keep the throttle down on it and let these guys do their job so I'm not wasting fuel until they break off. I also added these struts here, which are found underneath the structural part uh, of the pieces. So those break off just like a rocket that you've seen on TV. Those break off as the rocket launches. So we have several things in this stage that happen all at once. Solid rocket boosters kick off. We break away the supports. And we also have our liquid rocket goes off too, but it's going to be throttled down so we're not wasting any fuel. I have two large fuel tanks here that are going to be used for the main stage rocket booster taking it up. And then we can actually see here I put in a little control assist, which is actually found underneath the command and control. This little guy, it's a stabilizer, which means it has some spinning wheels inside of it that help us control our rocket, right? So that's going to make us a little bit easier, helps keep the whole thing stable in flight. Added a couple fins too to keep it stable in the atmosphere. We still have the single stage up here. I cut the amount of fuel on this in half. This tank is half the size of the last time we did it. Same swivel engine right inside here. And I wanted a smaller tank here so that way I'm pushing less mass. I don't want this to be quite so big. Up here, same stage brake, but I also added over here under the thermal part, I added a heat shield for when we go through re-entry so we don't eat up our command module too much and cook the person inside. That's not a good idea. Okay, so we want to make sure it's nice and comfortable for them when we're coming back through the atmosphere. Then we have our chute, and I think we are ready to rock and roll. We got our little rocket. So it's a real basic, looks kind of cool, but we're just going to keep building on this basic model as we go further and further here. I changed it to the desert launch site, which is my favorite. And it'll also change give you guys an idea. You can launch from different locations on Kerbal. So here we go. All right, we're at the desert launch site. Pretty cool. Now you can see I had a test little rocket that I put up in the orbit, and I ran out of fuel. So he's permanently up there in orbit. He can't get back. Maybe we'll do a rescue mission and go save him. But here we are on the desert launch site. Okay, and what we're going to do is we're going to put it at a orbital inclination of 270, which This guy's also at orbital inclination of 270. So basically what that means is that if I'm going to orbit around the planet in a circle. So I'm basically cutting the planet in half if I'm talking about its inclination. So this orbital path is on the heading of 270 and 090. So it's going right like this. If I was an inclination or an incline of 000, then I'd be launching due north. So I would go up north, right, up over the North Pole, and come down, and then come up from heading to 180. So coming up from heading 180 up to heading 000, right? So it's north south, right? And you can see that those inclinations are the cross section of the planet, or the plane that we're actually flying around the planet at. So that's what we mean by inclination. So I'm also going to launch this guy at heading 270. And what I'm going to do, kind of looking at it like this, is I'm going to burn straight up at about 10,000 meters. I'm going to turn it to 45 degrees towards 270, which is this way. And then I'm going to wait till the arch, or the apoapsis, gets up to the peak. I want it at about 100. And then at that point, I'm going to burn parallel to the surface of the planet as hard as I can in order to form a nice circle of path around the planet as my rocket is falling towards the planet. So basically, orbit is when your object, or whatever you're in, your spaceship, is burning along to the planet, but as you're falling towards the planet, you miss it because you're going around a ball, right? So it's constantly pulling you forward, and it's constantly going the other way, right? So here we go. We're going to go ahead and try to get this guy into orbit. And then we're going to try to bring him back too. So this video might be a little long, but I'm trying to make it as quick as I possibly can to show you guys how to do this stuff. All right, so let's go back to our ship. Okay, so we got our gimbal. We're going to turn on the SAS. I'm going to leave the throttle down, but I'm going to test it to make sure I can move it, right? But I'm going to leave it down. The first stage is going to kick out solid rocket boosters, the main stage engine. Okay, so let's get that going. Here we go. 3, 2, 1, launch. Actually fell back just a little bit. When you don't have enough thrust, it can actually fall down, and that's not good. Then you have a crash. Okay. So as these are going, we're at 1,700, going through the atmosphere here. This is the thickest part of the atmosphere. I want to keep it going below 300 if I can. That stage is done. Drop them off. Move the main stage up to full. Nudging towards my gravity turn here. $7,000 is okay to start the turn. A complete surround thing. Now in the tens, early tens. I'm sure NASA is probably trying to be a little more perfect on this stuff, but the rocket's a little wobbly. You can see that yellow circle right there. That's the direction the rocket's actually traveling. That's the physical travel vector, right? So that's the direction it's going. So the rocket's actually going about like right here, and I'm turning against that to try to move it, right? And then once I'm in place, the actual travel of the rocket and the point that my nose is heading should be pretty close. All right, go back to the map. Here's our apoapsis. Is at 37,000, 38, 40. And remember, we want to finish around 100,000. So 100 is nice and deep altitude, which interestingly enough, our stage is going to probably run out of fuel right where we want to be. As long as I'm above 80, I'm happy. I'm just going to let it go. 101. How about that? Okay, so here we go. Let's go ahead and kill the fuel, kill the throttle, stage. Look at that. Let that guy drop off. Now we want to point our nose towards the horizon on the gimbal, just like this. Now we're going to burn parallel to the surface of the planet when we get to the peak of the arch. So here we go. Here's our arch. Now you can time warp, but you don't want to go too crazy with it because it comes sooner than you think. And I usually stay in the map when I do this burn. Okay, time warp down. So I'm getting close. Go back to the horizon. Start throttling up. Oh, I'll turn my engine on. Remember, you gotta hit the stage. There we go. Watching the fuel. Okay, so now another little point is going to show up on our arch when it becomes a circle. We're going to circularize our orbit. And then a PE is going to show up over here, and that's the periapsis. That's the point of the circle that's closest to the planet. So as that gets bigger, eventually that PE will show up when it's outside of the body of the planet, and then we're going to wait until the PE swings around and tries to become, there it is, the AP. There we go. All right, so our PE is above 80, so that's good. It's not a perfectly circle. If we want to create a perfectly circle orbit, then we would just go back to this apoapsis. See, the apoapsis swapped over here, the peak. So it's most efficient to burn at the peak. But we are in orbit. So the way that we can, change our orbit in order to move around, and now whenever we're moving around in space, we're going to be moving around different celestial bodies. Okay, so Kerbin's a celestial body, the sun is a celestial body, Jupiter is a celestial body. All those are, floating around in space, big bodies that have mass and gravity. So we're just going to be transferring from one to the other. Now let's scroll out. Let's see what other celestial bodies we have here. Here we've got Kerbin, the first moon, the moon, Minimus. So we have two moons that we can play with, right? Here's some objects here, which are actually asteroids. We can go grab one of those later, right? Now, and we're around the celestial body of the sun. So now we're orbiting around the sun. And then we have their version of Mars, which is called Duna, right? And then we have Eve, which is their Venus. Moho, which is their Mercury, right? Drace, which is kind of a what is Drace's story? Oh, we can't go in and... Oh, we can go in and see it. Oh, looks like a little rocky body. Maybe we'll go check that out sometime. So each one has its own challenges in order to get to. So let's go ahead and get out of the map. I gotta change my target in order to get down here to be able to... Anyway, we're not really going to need that anymore. Okay, so I do want to be able to show you boss being buggy. Won't let me target it again. Okay, so this is what we're going to do instead. Now we're traveling around the planet on our orbital plane, right? So we're traveling prograde right now. So the directions, this is where I'm pointing the nose of the craft. So I'm going to point it prograde, which means along the line of travel, right? Because you can see that's where we're going. So now I'm going to actually go retrograde, which is going to burn the opposite direction, right? So this is what I'm going to do, is I'm going to, on my orbital speed here, I'm just going to drop it down by maybe 600 or so. And then we're going to be able to re-enter. I'd be able to show you on the map, but the map got all buggy on me, so we'll do that be seeing this again soon. But I'm going to start cutting this down. Now, if you were on the other side of the planet, you'd start seeing that the periapsis is dropping towards the surface of Kerbin. Okay, that's probably all that we needed. Now you'll see our altitude is starting to drop. We're falling towards the surface. And it won't take long till we start picking up some atmosphere. There we go. So now we're starting to enter the atmosphere. I'm still pointing retrograde, which means I'm pointing against the direction of travel. And you can actually see as we pick up this atmosphere, here it goes. You'll start seeing it on the hull. There it is. We're starting to hit some friction. Now what I want to do is get rid of some of this speed, and I can cut that friction down. So I'm going to use the last little bit of my fuel to burn retrograde until it's out. So I got about 200 meters a second off that, and now I'm going to break off that stage. So this final stage, break that off, and there it goes. I'm slowing down because I'm catching more friction in the atmosphere. The thicker the atmosphere, the more it's going to slow me down. So at the very top of this atmosphere, we might be hitting a little bit of it, but it can slow us down in several orbits. And then on a third orbit or fourth orbit, if I'm just grazing that atmosphere, it'll eventually drop me in. But we went in pretty heavy because we wanted to do it in one orbit in order to kill all that speed off. But of course, that generated a lot of heat. So thankfully, I have that heat shield. Not quite sure where I put us down at, but we're cruising over these mountains here. Losing some speed. I remember around 5,000 when I get down there, that's when I'm going to deploy my chute. Going far too fast right now to deploy it. There it is. Now, it might not look like it, but it's still very hot. Flying towards the surface. I can speed it up a little bit for video's sake. We're going to land in the mountains. That's cool. Here we go. Got my little guy in here, my little pilot. Ride of his life. Nice and smooth. Alright, so time warp. When you're time warping, you can't maneuver anything. And sometimes I was time warping it, didn't realize it, and I couldn't hit my chute. Oh, I'm going to deploy this and I'm trying to get close to the ground. And we died. Okay, so you guys get the idea. Unfortunately, our Kerbin did not survive that one because we hit a mountain, which was at 4,120 meters. So it was a big mountain. Miscalculation there, but that's okay. You guys get the idea. So on our next video, if it worked properly, it would have landed nicely. So play with that. Maybe keep your Kerbin alive. So in the next video, where we'll get a little bit more complicated, we're going to talk about rendezvous. So it means we're actually going to meet up with another ship in space and talk about how to do that. There's cool stuff you can do with it there, like transfer fuel and things like that. And then we can start getting really big ships and go a lot further once we figure that out. So anyway, that's orbit, and that's also orbital return and terrible landings. You have a wonderful day, and thank you for watching the video.